Welcome to Digital Control in Switch Mode Power Converters and FPGA based prototyping course. I'm Akshay Jain, working in SRE department of ST Microelectronics India. In this lecture, we will be discussing about the digital power based on STM32 microcontroller. In this lecture, we will be covering the following topics. We will be starting with STM32 overview and the digital SMPS overview, that is the switch mode power supply. Then we will be moving to STM32 microcontroller selection for the digital power applications. Here we will be covering the various peripherals. What are the main requirements for the digital power supply in terms of the microcontroller? Then we will be focusing mainly on STM32G4 series microcontroller, that is mainly developed for the digital power applications. Its internal architecture, what are the software tools, what are the hardware solutions that is built around STM32G4 for the development of the digital power supply. And in the end, we will be focusing around the complete ecosystem that is being provided by ST Microelectronics for the digital power supply applications. It's a family of a 32-bit microcontroller from ST Microelectronics. These microcontrollers are based on ARM Cortex-M processor. There are a large number of microcontrollers that is being present in STM32 family. Depending on our end applications and the user requirement, we need to select the right microcontroller for our requirement. STM32 family can be broadly classified into four categories. The first one is the mainstream MCUs, from which we can target all sort of industrial applications, be it a digital power, the motor control, or any sort of appliances. From high power MCUs, we can target the multiple core or the high speed applications. The third one is the ultra low power MCUs, from which we can target the battery operated applications where the power consumption is the main concern. The fourth one is the wireless MCUs, in which the dedicated module for the wireless connectivity is also present. Before moving forward, let's discuss the difference between analog SMPS and digital SMPS. In analog SMPS section, we have highlighted the internal architecture of a standard buck converter, where the output voltage is being sensed at the feedback pin of the controller and then compared with the set reference value, and correspondingly the PWM signal is being controlled. While in digital SMPS, the output voltage is being sensed at the ADC pin, compared it with the internal set reference value, correspondingly the PWM signal is being controlled to control the output voltage. Consider a first case if we want to change the output voltage. In analog SMPS, the set reference value is fixed, so we need to change the external hardware registers to change the output voltage. While in digital SMPS, we only need to change the set reference value that can be easily changed in the firmware, and correspondingly our output voltage can be changed. Consider a second case if we want to change the operating frequency. Though many analog SMPS are of fixed frequency, even if they provide the frequency change, we need to change the external hardware register. While in case of digital SMPS, we can easily reconfigure the timers to change or to operate our topology on a desired frequency. Consider a third case if we want to explore the different topologies. For the analog solutions, we need to have a dedicated IC for the dedicated topology. So basically the complete controller will be changed for the different topology. While in digital SMPS, only the power plant will be changed while the controller will remain same. So the single controller can able to manage various topologies. So this is the STM32G4 control card, which can be considered as a single digital controller that can be used for exploring various topologies. The digital switch mode power supply, or we can say that the power supply which is controlled by the microcontroller, not only control the power control loop but also had additional features like various parameters monitoring and communication, etc. From the previous slide, it is very clear that the digital control has several advantages over analog control. Higher system efficiency and power density, faster and flexible control loop depending on the input conditions and various load conditions. We can easily change the control loop on the go. Increase system level integration and design flexibility. So just changing the power plant, we can test or explore various new topologies. Improve system level reliability, monitoring and safety. Microcontroller peripherals required for digital switch mode power supply. So in order to control any SMPS digitally, the MCU should be equipped with the following peripherals. First one is the high speed clock. All the tasks which is written in the application layer should be executed as fast as possible. Advanced analog peripherals, it includes microcontroller internal comparators and op-amps. It is highly desired to have these comparators and op-amps in order to have various thresholds set for the various protections. High resolution ADCs and DACs in order to monitor various parameters accurately and setting the reference voltages for the various protections. High resolution timers for various control signals, mathematical escalators for the various trigonometric functions, data exchange peripherals in order to communicate with the external world. Our next topic is selection of STM32 for digital switch mode power supply. In the last slide, we pointed out the key peripherals required in microcontroller for digital power applications. The selection of MCU is very important. The MCU selected should not only contain the desired peripherals, but the MCU selected should also be optimized in terms of the power consumption, in terms of space. When we talk about space, we are talking about the package of the microcontroller, and it should be also be optimized in terms of cost. In the current slide, all the four categories of microcontroller within STM32 family has been highlighted. Correspondingly, various series of microcontroller associated with the particular categories has also been highlighted. The STM32F3 and STM32G4 series of the mainstream MCU is particularly meant for the digital power applications. In the subsequent slides, we will be focusing on STM32G4 microcontroller and understanding more about it. STM32G4 Overview. The STM32G4 is one of the advanced microcontroller series for digital power applications. On the left side, we have highlighted the key differentiating peripherals along with their technical specifications related to STM32G4, while on the right side, we have highlighted the safety and reliability aspects of STM32G4. The STM32G4 can easily target various topologies for AC-DC and DC-DC power conversion. There has been several hardware boards, several software examples available, which we will be covering in the later part of the slides. Also, STM32G4 is available in various packages. Depending on the peripherals requirement, depending on the pin count requirement, the end user can select the desired package from the available portfolio. One key features worth mentioning about the STM32G4 peripherals: any internal event of any peripheral or any external event can be made to synchronize with other peripheral just by the configuration. So this makes the small section of the code to work as an independent state machine. This part we will be understanding more deeply while we will be doing the STM32G4 configuration in STM32Cube MX. In this slide, internal block diagram of STM32G4 microcontroller has been highlighted. STM32G4 microcontroller can be operated from 1.7 volts to 3.6 volts. Normally it is operated at 3.3 volt input. It can have a maximum clock of 170 MHz with both options available of internal RC oscillator or external crystal. It has 7 internal comparators and 6 internal operational amplifiers. It has 5 ADCs with multiple channels. Depending on the package we have selected, the channels number can be decided accordingly. It has 12-bit DACs, 4 are internal while 3 are external. When we say internal, it is for the internal reference values, and when we say the externals, those DAC or basically the analog signals will be present on the pins of the microcontroller. Debugging, either we can go for the JTAG or SWD cable, where SWD stands for the serial wire debugger. GPIOs, almost all the pins of the microcontroller can be configured as a GPIO if they are not used for any other peripherals. High resolution timers, though this timer is one in STM32G4, but there are 12 PWM channels that can be generated from high resolution single timer. All the different PWMs can be synchronized according to our requirement. Apart from the high resolution timer, there are advanced timers, basic timers, which can be configured as per our own need. Apart from that, there has been several communication peripherals like SPI, I2C, UART, CAN and USB, which can be used for communicating with the external world. Up till now, we have covered STM32 family overview, where we found out that there are several series of microcontrollers from which Depending on our end applications and the user requirement, the right microcontroller need to be selected. Then we touched the digital power overview, where we found out that there are some key peripherals required within microcontroller to achieve the optimized digital power application. Eventually, we focused our attention on STM32G4 microcontroller. This microcontroller is being designed for the digital power applications. Now, for the application development that can be a bit tedious task, there are several tools from ST Microelectronics. The first software tool available from ST Microelectronics is STM32CubeMX. It's a graphic user interface tool. This tool is quite handy in generating the application firmware. This tool helps in the microcontroller selection, configuring various pins of the microcontroller, initializations of the peripheral, and eventually generating the first level of code for three different IDs, that is IAR, Kyle, and STM32Cube ID. The next session will be dedicated on STM32CubeMX, where we will be focusing on the initializations of various peripherals, the MCU pins configurations, and eventually generating the code. The second software tool requirements is the IDE, where the IDE stands for Integrated Development Environment. STM32CubeMX generates the initial workspace in three different IDEs: IR Systems, Kyle, and Eclipse. IR System is a paid version, while Kyle is free for the evaluation purposes only, while Eclipse is a freeware available from ST. Now, ID is required for the application development. It's more of a customized thing that is being required for the end applications and for the debugging purposes. For digital SMPS applications, there is a new tool called Digital Power Workbench under the umbrella of eDesign Suite is available on ST website. This tool assists in the application development one step ahead, as it provides a step-by-step optimized design of power section and control loop. There are several hardware platforms available for STM32G4 microcontroller evaluations. The first category is the STM32 Nucleo boards. These are very cost-effective general-purpose boards in which the microcontroller is in center, while all the GPIO pins are available at STMorpho connectors and some of the pins are available at Arduino Uno connector. These boards doesn't require any external debugger, as the debugger is mounted on top of it. All the STM32G4 Nucleo boards are listed here. Also, in STM32CubeMX, there are several examples based on Nucleo G4 series boards which can be evaluated, and based on the end user applications, those examples can be modified. Also, there are several X Nucleo boards that can be mounted on top of these Nucleo boards, and our end applications can be realized accordingly. In hardware solutions, the second category belongs to the discovery kits. These discovery kits has been designed and developed to evaluate specific applications. Like the first board has been designed and developed to evaluate USB Type-C connector interface and to evaluate buck boost converter application. The complete hardware and the firmware application details are already present on ST website, while the second board has been dedicated for motor control applications. MOSFETs and its related gate drivers are already mounted on it. The third category of the hardware evaluation tools belongs to the evaluation board. This eval board is a complete demonstration and development platform. The full range of hardware features available on the board helps the user to improve application development and to evaluate all the peripherals available on STM32G4. The last category belongs to the evaluation boards or the reference board from ST Microelectronics. These boards can be considered as a complete system. In digital switch mode power supply domain, there are several boards that has been designed and developed for evaluating several applications. It can be battery charging application, it can be for EV infrastructure, it can be for motor control, and many other several applications. There are large number of boards, while only some of them has been listed here. One thing worth mentioning here, all the STM32 Nucleo boards, discovery kits and evaluation boards are available for purchase directly from ST website, also from the distributor website, while only few evaluation boards or the reference board are available for direct purchase. But for all the evaluation boards or the reference boards, the complete schematic or the design details including the magnetics and the firmware application is present on st.com. In the subsequent lectures, we will be focusing on these two particular boards. The first board is the ST-2KW5CH48 volts. It's a 2.5 kilowatt LEV charger board. It can take input from 85 volts to 265 volts, and the output is for 48 volt battery charging applications. The front end is the continuous conduction mode PFC, while the DC-DC is full bridge LLC and subsequently the rectification, while the other board is the high voltage full bridge LLC converter. In the subsequent lectures, we will be focusing on the testing various waveforms. It is going to be really interesting. STM32G4 Digital Power Ecosystem. In the last couple of slides, we have discussed several software tools STM32Cube which not only helps in MCU selection, MCU pin configuration, clock management, but also assist in generating initial workspace with all peripherals initialized. Then we discussed several IDEs, Digital Power Workbench. Also, there are several hardware boards like STM32 Nucleo boards, Discovery boards, evaluation boards. There are several firmware examples that is being developed for STM32 Nucleo boards and Discovery boards. By evaluating those examples, it's not only assist in understanding the peripherals or the application working, but also reduce the time of the final product development. Apart from that, there are detailed documentation. There are several application notes which helps in understanding the various peripherals. For example, there is a dedicated HR team, that is high resolution timer cookbook, that helps us in understanding how to use high resolution timer for various topologies. Apart from that, there has been several videos on STM32G4 available on ST website under the category of digital power training. Concepts covered in this session. There are several industrial, consumer and automotive applications which require AC-DC and DC-DC converters in several topologies. Those converters not only require high integration, high efficiency and high reliability, but also it requires the flexibility to reconfigure. It can be a challenge to the analog solutions, but not for the digital solutions. This we have understood in comparison between analog SMPS versus digital SMPS. We also had an overview of STM32 family and STM32 digital power ecosystem. There are several hardwares and software tools to support and accelerate the development of digital power applications. In the next module, we will be covering STM32Cube tool and try to capture and learn every feature of it. Also, we will be covering the various firmware examples developed for STM32 Nucleo and STM32G4 evaluation board in STM32Cube tool. This enables a very quick start to real-time code and firmware writing. Thank you. Let's meet again in next session.